Hi, good morning. This is Dr. Abdul Rahim. Hope you're all doing well. So today's class is the continuation of the previous class. In the previous class, we discussed about the differential equation, what is a differential equation and how to find the order and the degree of the differential equations. So in the today's class we are going to discuss about the formation and solution of a differential equation, how the differential equations are formed and what are the different types of solutions for a differential equation. So those two things we are going to discuss today. Okay, so we have to obtain the differential equation from the given equations. You have to follow some certain procedures to form the differential equations. What is that procedure? Let us see it. So step one, differentiate the given function with respect to the independent variable present in the given equation as many times as the number of arbitrary constants. So this is the first step what we have to do. First of all, from the given equations you have to find out how many arbitrary constants are given. um, Depending on the number of arbitrary constants, you have to differentiate those many times. So you have to differentiate those many times. If there are two arbitrary constants, you have to differentiate two times. If there is only one arbitrary constant, you have to differentiate only one time. If there are three arbitrary constants, then you have to differentiate the given equation three times. So then step two, from these equations, so we have the given equation and the differentiated equations. So from these equations, obtain the differential equation by eliminating the arbitrary constants. So once you eliminate the arbitrary constants from the equations which we got and including the equation which is given, so we can form the differential equation. So these two steps you have to follow to obtain the differential equations. Okay. So what is that step? So first of all, observe the equation and see the number of arbitrary constants given in the given equation. So depending on the number of arbitrary constants, you have to differentiate those many times to obtain the equations. Then the next step is eliminate from these equations, obtain the differential equation by eliminating the arbitrary constants. Once you eliminate the arbitrary constant, then you will get the differential equations. So we are not going to solve, we are not going to form the differential equation, just it is an example. In the next video, we are going to discuss about the formation of differential equation solution. Okay, so find the differential equation of the family of the straight lines y is equals to mx plus c when m is an arbitrary constant. So this is the equation given. So y is equals to mx plus c. This is the equation of the family of straight lines. Here in the first question, it is given as m as arbitrary constant. So now to obtain the differential equation for this, what you have to do, since there is only one arbitrary constant m as an arbitrary constant, you have to differentiate only one time. So then this equation and the differentiated equation, if we use those two equations and eliminate m, then you will get the differential equation. Similarly here in the second question, he has given m and c, both are arbitrary constants. So that means there are two constants. So therefore in this case, what we have to do, you have to differentiate the equation two times, then you will get these two equations and this one equation. So three equations. From three equations, you have to eliminate both m and c to obtain the differential equation. So that is the procedure you have to employ to form the differential equations. It is simple. Okay. So the first step is identify the number of arbitrary constants. Depending on the number of arbitrary constants, you differentiate the equation those many times. So then you will get n plus 1 equations. So from the n plus 1 equations, you have to eliminate the arbitrary constant, then you will get the differential equation. Okay. So in the next video, we are going to obtain the differential equations. Okay. So just here only the theory part is given. Okay. So next coming for the solution of a differential equations. So there are two types of solutions for a differential equation. The first one is the general solution and the second one is the particular solution. So what is the general solution? A relation phi of x comma y comma k1 k2 so on kn is equals to 0, where k1 k2 are n arbitrary constants, is said to be a general solution of the differential equation f of x comma y1 y2 so on yn is equals to 0 if phi of x comma y comma k1 k2 so on kn is equals to 0 is the solution of the function. Okay, so if this will become the solution of this one, then this is called the general solution of the differential equation. Okay, so now coming for the particular solution. If phi of x comma y comma k1 k2 so on kn is equals to 0 is a general solution of the differential equation f of x comma y1 y2 so on yn is equals to 0, then phi of x comma y comma d1 d2 so on dn is equals to 0, where d1 d2 are so on d1 d2 so on dn are fixed constants, is called the particular solution of the given differential equation. So these are the different types of solutions for the differential equation. So here we are not doing the finding the solution, just here only the theory part. In the next video we are going to solve the problems for finding the solution and as well as the formation of a differential equations. Okay, so what we have discussed today, let us recap it. So we have study about how to what is the procedure that has to be employed to form a differential equations. So the procedure is, first of all, you have to write down the given equation. So from the given equation